We'll start in about a minute. We'll cover two sections today, Chapter 8, Section 6, and Chapter 8, Section 8. Section 8 won't take too long. In Section 6, we'll solve equations with radicals, and then in Section 8, we'll discuss the complex number system. Okay, in Section 8.6, solve equations with radicals. So how to solve equations with radicals will be explained shortly. But first, this comment: after solving an equation with one or more radicals, it is important to check the answers because of the possible occurrence of extraneous solutions. An extraneous solution is a solution that emerges from a process maneuver that is not a solution to the original equation. Hey, in our first example, solve the following equation for the variable. We have the square root of 4x minus 3 equals 7. First note that this is the positive square root, or principal square root. So this has to be equal to a number that's not negative. And so far, we're okay because the right-hand side is not a negative number, it's positive 7. To solve for x, we need to get x out of the square root. So since x is inside the square root, what we do is we square both sides. So we square the left-hand side, we square the square root of 4x minus 3, and we square the right-hand side, 7 squared. Okay, so the square root of 4x minus 3 squared, this isn't necessary, but just to remind you, when you square something, you multiply that something by itself. So we're going to multiply the square root of 4x minus 3 times the square root of 4x minus 3. And 7 squared is 7 times 7, or 49. And the left-hand side becomes 4x minus 3. So 4x minus 3 equals 49. Add 3 to both sides. We get 4x equals 52. Then divide both sides by 4, x is 13. And then just get into the habit of checking your answers. When you replace x in the original equation with 13, so up here we'll check. Replace x with 13, so we have 4 times 13 minus 3 inside the square root. 4 times 13 is 52. 52 minus 3 is 49, so we get the positive square root of 49 equals 7. And that's true, so x equals 13 is the solution. Okay, the next equation, we have the principal square root of 2x minus 5 equals negative 3. So based upon what we've discussed so far, how should we proceed with this equation. So what should we do to start with? If you don't know, you can say, I don't know. Or if you do know, you could type in what we should do to start with. Okay, so someone said square both sides. Okay, let's square both sides. When we square both sides, we square the square root of 2x minus 3. On the right-hand side, we square the number negative 3. And when we square the square root of 2x minus 3, we get 2x minus 3. And when we square negative 3, we get positive 9. Then this is an easy equation to solve. Add 3 to both sides, we get 2x equals 12. Then divide both sides by 2, we get x equals 6. Okay, then to check, so we check this. In the original equation, square root of 2 times 6 minus 5. 2 times 6 is 12. 12 minus 5, let's see, it used to be 2x minus 5, not 2x minus 3. Yeah, you're right. I knew I was making a mistake somewhere. So yeah, the square root of 2x minus 5 squared is 2x minus 5 equals 9. Then when we add both sides, we get 2x equals 14, or x equals 7. Okay, so when we check x equals 7, we get the square root of 2 times 7 minus 5, which is the square root of 14 minus 5, or the square root of 9, which is 3. But 3 equals negative 3 is false. Okay, so we came to the right conclusion. There's no solution. X equals 7 is extraneous. Okay, but we did more work than was necessary. The original equation is saying or claiming that a positive number equals negative 3. The left-hand side cannot be negative because it's the positive square root of 2x minus 3. So the original equation is false. But even if you don't recognize it, you should still come to the correct solution by going through the process. Okay, let's solve the next equation. The square root of 6x minus 4 and then plus 2 equals 10. So before squaring both sides, we want to isolate the square root. So the first thing to do is to subtract 2 from both sides. So we get the square root of 6x plus 4 equals 8. Everything is okay so far. The left-hand side is the positive square root of 6x plus 4, and the right-hand side is positive. So we're okay so far. Now we square both sides. square the square root of 6x plus 4 on the left-hand side and square 8 on the right-hand side. When we square the square root of 6x plus 4, we just get 6x plus 4. When we square 8, we get 64. Then subtract 4, we get 6x equals 60, and divide both sides by 6, we get x equals 10. Hey, in the original equation, to check, replace x with 10. We have the square root of 6 times 10 plus 4 plus 2. 6 times 10 is 60. 60 plus 4 is 64. The square root of 64 plus 2 is 8 plus 2 equals 10. That's true. So x equals 10 is the solution. Okay, the next one is a little more complicated. The first step is going to be the same as before. We have the square root of x squared minus 5x equals 6. So we want to solve for x, so we're going to square both sides. So square the left-hand side and square the right-hand side. When we square the square root of x squared minus 5x, we get x squared minus 5x, and that's equal to 36. And we get to review how to solve quadratic equations. We'll try to solve it by factoring. That means we want one side to be 0. So we'll subtract 36 from both sides. And now we'll solve by factoring. Okay, to factor x squared minus 5x minus 36, we can use the AC method. 1 times negative 36 is negative 36. And two integers that have a product of negative 36 and a sum of negative 5 are negative 9 and positive 4. So negative 9 and positive 4. I'll remind you of the abbreviated AC method. When the coefficient of x squared is 1, we can just use the integers that we find, negative 9 and 4. So one of the factors is x minus 9. Since positive 4 is the other number, the other factor is x plus 4. And you can verify the factoring by multiplying if you're in doubt that you have the correct factors. But you can tell by looking that we have the right factors. The two solutions to this equation are x equals positive 9 and x equals negative 4. Okay, but remember what the original equation is. So we should check. So we'll check x equals 9 first. So we have the square root of 9 squared minus 5 times 9. 9 squared is 81 and minus 45 is 36. So we get the positive square root of 36 equals 6. That is true. So x equals 9 is a solution. Then when we test or check x equals negative 4, replace every x with negative 4. So we have the square root of the number negative 4 squared minus 5 times negative 4. The number negative 4 squared is positive 16, and we're subtracting negative 20, which is 16 plus 20, so we have the positive square root of 36 equals 6, and that is also true. So both of those numbers, positive 9 and negative 4, are solutions. Hey, the next page. So this time we have the square root of x plus 7 equals 2x minus 1. So the right-hand side has a variable in it, so since x could potentially be positive or negative, we can't tell from the outset if there are going to be extraneous solutions or not. We have to go through the process. But since the square root of x plus 7 is by itself, we can square both sides. So square the left-hand side and also square the right-hand side. So remember what it means to square something. So I'm going to remind you of what to do when you square the binomial 2x minus 1. Sometimes students forget how to square a binomial. When we square the square root of x plus 7, well, I'll go ahead and write it. It's the square root of x plus 7 times the square root of x plus 7. And when we square 2x minus 1, we multiply 2x minus 1 times 2x minus 1. On the left-hand side, the square root of x plus 7 times the square root of x plus 7 is just x plus 7. On the right-hand side, 2x times 2x is 4x squared, and then minus 2x times 1. And then we multiply negative 1 times the binomial 2x minus 1. Negative 1 times 2x, we get minus 2x again. And then negative 1 times negative 1 is positive 1. So let's write x plus 7. We'll simplify the right-hand side. X plus 7 equals 4x squared minus 4x plus 1. And we have a quadratic equation, so we'll set one side equal to 0 and then attempt to solve by factoring. We will subtract x from both sides and subtract 7, and that gives us 0 equals 4x squared minus 5x minus 6. Okay, to solve by factoring, well, we have a little more work to do on this one. If we factor by the AC method, so we're going to multiply 4 times negative 6, which is negative 24. And two numbers that have a product of negative 24 and a sum of negative 5, or negative 8 and positive 3. So 4x squared minus 5x minus 6, we're going to transform that into a quadrinomial. So I'm going to write 4x squared minus 8x plus 3x minus 6 equals 0. Then we factor by grouping. Out of the first two terms, the greatest common factor is 4x. So 4x times x minus 2, and then plus 3 times x minus 2. And our two factors are x minus 2 and 4x plus 3. Okay, so the quadratic equation has two solutions. One is x equals 2. The other one is x equals negative 3/4. Okay, so we should test those. So at the top of the page, we'll test or check x equals 2. So replace every x with 2. We get the square root of 2 plus 7 on the left-hand side and 2 times 2 minus 1 on the right-hand side. And this is going to turn out to be true. The positive square root of 9 equals 4 minus 1, or 3. That's true. Okay, so x equals 2 is that solution. And then when we test x equals negative 3/4, so inside the square root, we have the square root of negative 3/4 plus 7, but I'm going to rewrite 7 as 28 over 4 because we want a common denominator. Okay, but notice the right-hand side, 2x minus 1, that's 2 times negative 3/4 minus 1. This is going to be negative. The left-hand side is positive. So if we take it a little bit further, the square root of negative 3/4 plus 28/4 is the positive square root of 25/4. And the right-hand side is negative 3/2 minus 1, or negative 5/2. And that is false. So negative 3/4 is not a solution. Only x equals 2 is a solution. Okay, in the next example, we do the same sort of thing. Here we have x plus 6 equals the square root of 2x plus 12. The square root of 2x plus 12 is already isolated by itself, so we can square both sides. So when we square x plus 6, we multiply x plus 6 times x plus 6. And when we square the square root of 2x plus 12, we multiply 2x plus 12, the square root of 2x plus 12 times the square root of 2x plus 12. And x plus 6 times x plus 6, we get x squared plus 6x plus 6x for a total of plus 12x, and then plus 6 times 6, which is 36. And on the right-hand side, the square root of 2x plus 12 times the square root of 2x plus 12 is just 2x plus 12. Okay, we get another quadratic equation, so we'll set one side equal to 0 by subtracting 2x from both sides and subtracting 12 from both sides. And then x squared plus 10x plus 24, we can factor that. We can use the abbreviated AC method. So two integers that have a product of 24 and a sum of 10 are positive 6 and positive 4. So I'll make a note of that, 6 and 4. So we can write the factors as x plus 6 times x plus 4 equals 0. And the quadratic equation has two solutions, x equals negative 6 and x equals negative 4. Okay, we'll check negative 6. On the left-hand side, negative 6 plus 6. On the right-hand side, the square root of 2 times negative 6 plus 12. And we get 0 equals the square root of 0. That's true. There's nothing wrong with that. So x equals negative 6 is a solution. And then check x equals negative 4. So on the left-hand side, we have negative 4 plus 6. On the right-hand side, the square root of 2 times negative 4 plus 12. Negative 4 plus 6 is positive 2. On the right-hand side, the positive square root of negative 8 plus 12, or 4. That is also true. So x equals 4 is also a solution. Okay, the next problem this time we have 5 times the square root of x equals x plus 6. So on this one, since we have a numerical factor that we're multiplying by the square root of x, in this case, it's easier just to start out by squaring both sides. So we have 5 times the square root of x squared, and the right-hand side, x plus 6 squared. Okay, so this is another one of those that can create a problem if you're not careful. So 5 times the square root of x squared, that means 5 times the square root of x times 5 times the square root of x. And x plus 6 quantity squared is x plus 6 times x plus 6. And on the left-hand side, 5 times the square root of x times 5 times the square root of x is 25x, because 5 times 5 is 25. And the square root of x times the square root of x is x. On the right-hand side, x plus 6 times x plus 6 is x squared plus 6x plus 6x a second time for a total of plus 12x, and then plus 36. Okay, now we'll subtract 25x from both sides, and we'll get 0 equals x squared minus 13x plus 36. We can solve this by factoring. We can use the abbreviated AC method since the coefficient of x squared is 1. So two numbers that have a product of positive 36 and a sum of negative 13. What are those numbers? So what two integers have a product of positive 36 but have a sum of negative 13? Both of them have to be negative. If the product is positive and the sum is negative, both have to be negative. Okay, negative 9 and negative 4. Negative 9 and negative 4. When you multiply them, you get positive 36. And when you add them, you get negative 13. Okay, the coefficient of x squared is 1, so we can use the abbreviated AC method to write down the factors. Since one of the numbers is -9, one of the factors is x minus 9. The other number is -4, so we can write x minus 4. And this equation has two solutions, x equals +9 and x equals +4. Okay, when we check these, we'll check x equals 9 first. 5 times the square root of 9 is 5 times 3. And the right-hand side is 9 plus 6. Both of those are equal to 15, so that's true. When we check x equals 4, 5 times the square root of 4, that's 5 times 2. And the right-hand side, x plus 6, 4 plus 6 is 10. Both of those are equal to 10. So both of those numbers, 9 and 4, are solutions. Both are solutions. Okay, now we're going to switch to a different type of, or a different kind of radical. This time we have the cubed root of 2 plus 9x equals 9. So we want to solve for x. X is inside the cube root, or it's inside the radical with index 3. So what do we have to do? This time we're going to raise both sides to the third power because it's a cube root instead of a square root. So we're going to raise the cube root of 2 plus 9x to the third and raise the right-hand side 9 to the third power. So the cubed root, or sorry, the cube of a cubed root of something is just that something. So the left-hand side simplifies to 2 plus 9x. And 9 to the third, 9 times 9 times 9 is 729. And then subtract 2. We get 9x equals 727. And then divide both sides by 9, we get x equals 727 divided by 9. This fraction cannot be written in lower terms. So this one's easier to check than you might imagine if we just replace x with 727 over 9. We have 2 plus 9 times 727 over 9. The 9's cancel, so we get the cube root of 2 plus 727, which is the cube root of 729. 729 is a perfect cube, which is equal to 9. So the resulting equation is true. So x equals 727 over 9 is the solution. Okay, in the next example, we have the fourth root of y plus 8 equals 5. We want to solve for y. We see that y is inside the radical with index 4. So how are we going to solve for y this time? So we start by raising both sides to the fourth power. So the fourth root of y plus 8 to the fourth equals 5 to the fourth. On the left-hand side, when you raise the fourth root of y plus 8 to the fourth, you just get y plus 8. And on the right-hand side, 5 to the 4th is 625. Then subtract 8, we get y equals 617. So this one is easy to check. You can do it visually. If you replace y with 617, you get the 4th root of 625, which simplifies to 5. Okay, the next one, the 5th root of 2 plus 17x equals negative 2. So what about this one? This one involves a 5th root, and since 5 is an odd integer, it is possible for radicals with odd numbered indexes to be negative. So there's nothing wrong with this. If the index were even and the right-hand side was negative, then there would be no solution. But we're okay. The 5th root of a number could be equal to a negative number. So we start by raising both sides to the 5th power. So the 5th root of 2 plus 17x to the 5th is equal to the number negative 2 to the 5th. And the 5th root of 2 plus 17x to the 5th is just 2 plus 17x. The number negative 2 to the 5th is negative 32. Okay, then solve for x. So subtract 2 from both sides, we get 17x equals negative 34. Then divide both sides by 17, we get x equals negative 2. So this one's easy to check also. Replace x with negative 2. You get the 5th root of 2 plus negative 34, or the 5th root of negative 32, which is equal to negative 2. That's true. Okay, we'll spend the next few minutes in section 8.8. This is an introduction to complex numbers. The complex number system is complicated enough that entire courses are devoted to complex number theory. But we're only going to do the very basic thing with complex numbers. So let's start out. We know that the square root of a negative real number is not a real number, but it is a certain type of number. It is a non-real complex number. So each non-real complex number can be written so that the square root of negative 1 appears in its construction. And here's a definition. The imaginary unit is I equals the square root of negative 1. It's just a definition. So instead of always writing the square root of negative 1, we can just use I in its place. It's probably just done for convenience, so you don't always have to write the square root of negative 1. Okay, but note that if I equals the square root of negative 1, if you square both sides, then I to the second is equal to negative 1. So these are the two things that you need to remember. And when simplifying square roots of negative numbers, we're going to use some of the same things that we've been using. So we'll simplify the square root of a number of negative numbers. The square root of -4, you can think of this as the square root of 4 times the square root of -1. Here we're just using the product property of square roots that we saw earlier this semester. And then we simplify. The square root of 4 is 2, and instead of writing the square root of -1, we just replace it with I. So 2 times I is what we get when we simplify the square root of -4. So that's about all there is to it. The square root of -9, think of that as the square root of 9 times the square root of -1, because 9 times -1 is -9. The square root of 9 is 3, and the square root of -1 is I. So when we simplify the square root of -9, we just write 3 times I. The square root of -16, think of that as the square root of 16 times the square root of -1. The square root of 16 is 4, and by definition, the square root of -1 is I. Square root of -25, think of that as the square root of 25 times the square root of -1. The square root of 25 is 5. The square root of -1 is I. So 5 times I is what we get when we simplify the square root of -25. Well, as you would expect, we'll get more complicated square roots. But the answer is still, the simplified answer is still going to involve I. So this one, the square root of -8, we can start by writing the square root of 8 times the square root of -1. And then we simplify the square root of 8. So we can think of the square root of 8 as the square root of 4 times the square root of 2. And we will replace the square root of -1 with I. And then the square root of 4 is 2, so we get 2 times the square root of 2 times I. So if you have a square root of a positive number multiplied by I, you'll want to make sure that you don't inadvertently put the I inside the square root, either when you're writing it or when you're typing in answers in Newton. It's an easy little mistake to make. Just make sure that it's never inside the square root. Okay, the next one, the square root of -27. So write this as the square root of 27 times the square root of -1. Simplify the square root of 27. The largest factor of 27 that's a perfect square is 9. 9 times 3 is 27. So we get the square root of 9 times the square root of 3 times I. The square root of 9 is 3. So we get 3 times the square root of 3 times I. One thing that you might see, just to avoid any misunderstanding, is to rearrange these factors and write it as 3 times I times the square root of 3. If you're careful, you can put I on the right. Just make sure it's not inside the square root. Okay, the next one, the square root of -80. Write this as the square root of 80 times the square root of -1. And we can simplify the square root of 80. The largest factor of 80 that's a perfect square is 16. 16 times 5 is 80. So this is the square root of 16 times the square root of 5. And then replace the square root of -1 with I. And then the square root of 16 is 4, so we get 4 times the square root of 5 times I. Okay, so now let's just practice. If you understand the concept, the square root of -175, square root of 175 times the square root of -1. We can simplify the square root of 175. The largest factor of 175 that's a perfect square is 25. 25 times 7 is 175. So rewrite this as the square root of 25 times the square root of 7 times I. And then the final answer, simplified result is 5 times the square root of 7 times I. Okay, we'll keep going until we run out of problems or run out of time. The square root of -112, write that as the square root of +112 times the square root of -1. So I'll let you answer a couple of questions. What's the largest factor of 112 that is a perfect square? Largest whole number factor of 112 that's a perfect square. Hey, 16. 16 times 7 is 112. You could start out with 4. You could do 4 times 28, but then you'd note that 28 has a factor of 4 that's a perfect square also. So altogether, 16, 112, we rewrite that as the square root of 16 times the square root of 7, and then replace the square root of -1 with I, and then our simplified result is 4 times the square root of 7 times I. Okay, the next one, the square root of -500. Rewrite that as the square root of 500 times the square root of -1. The largest factor of 500 that's a perfect square is 100. 100 times 5 is 500. So this becomes the square root of 100 times the square root of 5 times I. Square root of 100 is 10, so we get 10 times the square root of 5 times I. Okay, the next one, the square root of -99. First step, write it as the square root of +99 times the square root of -1. And the largest factor of 99 that is a perfect square is 9. 9 times 11 is 99. So we write the square root of 9 times the square root of 11 times I. The square root of 9 is 3, so we get 3 times the square root of 11 times I. Here there's less than a minute left, but we can cover this next part. A complex number can be written in the form a plus b times I, where a and b are real numbers, and I is the square root of -1. And we say that the real part of a plus bi is the real number a, and we say that the imaginary part of a plus bi is the real number b. It's like the coefficient of I. And note that every real number is a complex number whose imaginary part is 0. As an example, the real number 7 can be written as 7 plus 0i, 0 times I, where I is the square root of -1. Okay, that's all we have time for today. Remember, test 3 is on Thursday. Tomorrow and Wednesday, we will review for test 3. But that is all for today.